Welcome to Think Mastermind 10th Standard Mathematics Relations and Functions. Before watching this video, please subscribe and click on the bell button.
Hello students, welcome to Think Mastermind. Seventh problem in exercise 1.4. Solution is, here the given f is a function from real valued function from R to R and f of x is defined is equal to 2x plus 1. The question is, state whether the given function is bijective or not. So bijection function is nothing but f is 1 to 1 and onto. Onto means the range is equal to codomain. 1 to 1 means distinct element in X has distinct image. We have to prove f is 1 to 1. That is enough to prove that if f of x1 is equal to f of x2, then x1 is equal to x2. So f of x is defined as 2x plus 1. F of 1 is 2x1 plus 1 is equal to 2x2 plus 1. So 1, both side of 1 cancelled. That is 2x1 is equal to 2x2 and 2 both side cancelled. Therefore x1 is equal to x2. That implies f is 1 to 1. So now we have to check that f is onto. So since we know that f of x is equal to 2x plus 1, that is y is equal to 2x plus 1, where x comma y is belongs to R, then finding the pre-image, that is x can be written as in terms of y, that is 1 becomes this side, that is y minus 1 divided by 2. So y is also belongs to R. For all values of y, there exists image x in R. Therefore range is equal to codomain. Therefore given function f is 1 to 1 and onto. So therefore f is bijection. Second question, f of x is equal to 3 minus 4 times of x squared, that is f of x1 is equal to f of x2. That implies 3 minus 4 times of x1 squared is equal to 3 minus 4 times of x2 squared. I will take 3 other side, it becomes minus 3. So 3 are cancelled and minus 4x1 square is equal to minus 4x2 squared. So minus 4 cancelled on both sides. That is x1 square is equal to x2 squared. That implies x1 is equal to plus or minus x2. Therefore f is not 1 to 1 function. Now we have to prove that on 2, substitute f of 1, that is 3 minus 4 4 into 1, that is minus 1. Similarly, f of minus 1, that is 3 minus 4 of minus 1 the whole square, that is also minus 1. Therefore, 1 comma minus 1 and minus 1 comma minus 1, both element in A has same image. Therefore, F is not onto. Therefore, F is not bijection. Suppose here we are taking the pre-image in terms of y. So here we have x squared. It becomes square root of plus or minus. Therefore, if prove like this, it is enough to prove it is not onto. Eighth problem in exercise 1.4. Solution is given f is function from a to b, it is onto function, and f of x is defined as ax plus b. Find a and b value. A is given as minus 1 plus 1 and b is given 0 2. So f is defined from a to b, it is onto. There is two possibilities. Minus 1 is mapped with 0 and 1 is mapped with 2. Then f of minus 1 is equal to minus a plus b, that implies minus a plus b is equal to 0. 1 is mapped with 2, therefore f of 1 is plus a plus b, that implies a plus b is equal to 2. From 1 and 2, solving this equation by elimination method, so 1 plus 2, that is minus a plus b is equal to 0 and a plus b is equal to 2. Solving this, it is cancelled. Therefore, 2b is equal to 2, b is equal to 1. Substitute b is equal to 1 any one of the equation, that implies a is equal to 2 minus b, that is 2 minus 1, it is equal to 1. Therefore, a is equal to 1. So another possibility of a and b values, suppose minus 1 1, the b is 0 to 2, minus 1 is mapped with 2 plus 1 is mapped with 0, then f of minus 1 is equal to minus a plus b, that implies minus a plus b is equal to 2. Similarly, f of 1 is equal to a plus b, that is a plus b is equal to f of 1 is mapped with 0. This equation is 2, this is 1. Solving 1 and 2, again you're getting b is equal to 1. Substituting b is equal to 1 in any one of the equation, getting a is equal to minus b, that implies a is equal to minus 1. So we have to discuss two cases. Therefore, a is equal to plus 1 if b is equal to 1, and also a is equal to minus 1 if b is equal to 1. Ninth problem in exercise 1.4, given that f of x is equal to set of all x plus 2 when x is greater than 0, and f of x is equal to 2 in the interval minus 1 to plus 1, and x minus 1, that is -3 to -1. Represent on real line. Suppose I'm taking the real line as -infinity to +infinity. So your middle is x is equal to 0, and here the interval is splitted like that, x is greater than 1. So here I'm taking 1. So x is greater than 1, that is x takes value 1 to infinity. The f of x defined as x plus 2. Next, the interval -1 to +1. So you have to check it is less than or equal to. Both inequality is in less than or equal to. Therefore, you include the -1 and +1. So from -1 to +1, the f of x is defined as 2, that is constant function. Next, the interval between -3 to -1. So that is before -1, it is an open interval. Before -1 to -3, the function f of x is defined as x minus 1. Now our question is find f of 3. So f of 3, it is a positive number. It is lies in the interval 1 to infinity. So f of 3 is 3 plus 2, that is equal to 5. And next find f of 0, that is x is equal to 0, that is lies between the interval -1 to +1. In the interval -1 to +1, for any value of x, the f of x value is 2. Next, f of -1.5, so that is greater less than -1 and greater than -3. Therefore, -1.5 is lies between the interval -3 and -1. Therefore, the corresponding function is x minus 1. Therefore, -1.5 minus 1, that is -2.5. Next, fourth one, find f of 2 plus f of minus 2. F of 2 plus f of minus 2. F of 2 is positive value. It lies between the interval 1 and infinity. Therefore, f of 2 is 2 plus 2 plus f of minus 2. Minus 2 lies between -3 and -1. The corresponding function is f of x minus 1. Therefore, f of minus 2 is -2 minus 1. Simplify this. 2 minus 2 cancelled. 2 minus 1 is 1. So this is required answer.
Hope this video is useful for you. Please subscribe and click on the bell button.